Relation representations, representing relations. So you got what is a relation? It's a rule connecting two different sets of values. So one natural way to represent relations would be to use a table. Speed, ticket price. All right, you're 5 miles over the speed limit and you got to pay $60. You're 10 miles per hour over the speed limit, you got to pay $90. You're 15 miles per hour over the speed limit, you got to pay $150. Okay, this would be a table showing connections or rules between speeds and prices. Another way that we can show a relationship between two different sets is use a graph. So if we had, that would show a relation between x values and y values. So we would know that when x is 0, y is 12. For example, when x is -6, y is 8. Okay? So a graph can show a rule or relationship, a connection between x's and y's. Ordered pairs that I just put up there is another way to show connections between x's and y's, two different sets of values. Something that's similar to a table, it's called a mapping. A lot of times they'll draw ovals, but you could really have any shape. You put your domain, your inputs in one of the ovals. So dog, fish, bird. Put your outputs in another circle, and then you connect your inputs to your outputs with arrows. So dog, 3 letters. Fish, 4 letters. Bird, also 4 letters. Okay? One set of values, another set of values connected according to some rule. In this case, the rule is how many letters does the input have? All right. Another way that you could show relations is through words. All right, you could have a word problem. It's showing a connection between sugar in cookies and how many batches grandma bakes. All right, so that's another way that you could show relations. The last way, most common maybe in mathematics, would be to represent a relation using an equation. Usually when we do this, we write it in this format that you might remember from Algebra 1. Okay, the name of the relation, R, the name of the input variable, X, equals, and then your rule, something like x squared minus 3x plus 5. And if I have my rule written that way, then if I want to find what does this rule do to individual inputs, we write them like this. If I want to know what is the value of R when I input 6, we would have R of 6. That's how you would write it. What does R equal when I input 6 for X? And then I would solve it. 6 squared is 36 minus 3 times 6 is 18 plus 5 is 23. Okay? And how would I do that? I'm replacing X with 6. So 6 squared minus 3 times 6 plus 5. I either would type that into a calculator or use my order of operations to solve. Okay? And if I wanted a different value, I would do, R of -1 equals. Okay? That would just mean replace X with -1. See if you can do that. All right, I think you should come out with something like 7 on that. Double checking, Negative 1 squared is negative 1 times negative 1. That's positive 1. Ooh, I think I messed up. Minus 3 times negative 1. That is positive 3. All right, plus 3 plus 5. All right. So just come out with something like 9. All right. Anyway, that's different representations of relations. And if I want to identify the inputs and outputs, the domain and the range, input and output for a set, it's a couple different ways, obviously, because there's so many different ways to represent it. There's a lot of different ways to represent what are my inputs and what are my outputs. In a mapping, it's very simple. The arrow goes from the input to the output. So one of your circles, the circle from which the arrows begin, would be your domain. Whatever's in there would be your domain. And the things in the circle where the arrows go to, that would be your range. Okay. Similarly, in a table, usually the column on the left would represent your domain, 15, 20, and 35. The column on the right would represent your range. Okay. If you have ordered pairs, X values are domain, Y values are range. So if I was going to list out the domain and range for this specific set, I would say my domain is, and usually when you're listing domain, you go from smallest to biggest. So negative 1, 8, 12, negative 1, 8, 12. And my range is, again, listing from smallest to biggest, Y values, negative 2, 5, 16. I notice that I don't care about whether they link up together, the negative 1 and the negative 2, they don't link up together. I just want my domain to be in order from smallest to biggest, my range to be in order from smallest to biggest. So if I have ordered pairs, list my X values, list my Y values. Same kind of thing if I have discrete data, individual points on a graph, and I'm asked for a domain, I'm going to list the X values for those points. And then if I'm asked for range, I'm going to list the Y values for those points. If I have continuous data, then I'm going to look domain, what is the leftmost edge, what is the rightmost edge of my data, and I'm going to say that X goes from something to something. So from negative 8 to positive 12, okay? And for my Y values, same kind of thing. I'm going to say, what is the lowest Y value that I have? What is the highest Y value that I have? And I'm going to say Y goes from something to something. All right, so that would be listing a domain and a range for continuous data. Basically, we're boxing in the graph and saying what is the possible, what are all possible values of X and Y for that rule. And then for equations, that's the hardest time to really identify domain and range. A lot of times we say all real numbers are possible, and then we list exceptions. So like, for example, if you have this fraction, n is not allowed to be 2 in this function, because if it is, we'll have 2 minus 2 in the denominator, 0 in the denominator. And remember, from middle school and through most of high school, you're not going to be allowed to divide by 0 in the denominator. So we would say the domain, the allowable inputs for this are anything except for n is 2. Outputs, you almost have to know what a graph looks like, or have a feel for what a graph looks like, because sometimes, for example, if you have a parabola, okay, it's going to open up one direction, and then you're almost thinking like this, right? What can Y be? Well, it can be anything above negative 6, for example. Okay, so your range would be limited There'd be a lower bound, but no upper bound. Okay. But anyway, a domain is what are my possible input values? List all my possible input values if there's discrete data, or my input values go from this to this if it's continuous data. And range is what are all my possible output values. Using that definition of functions, a function is a relation for which each input has exactly one output. Again, looking through all of the different ways that we could represent functions, how would it look for something to be a function? How would it look for it not to be a function? All right, it's a lot easier to identify things that are not functions than it is to identify functions. Okay, this is a function. This is a functional relationship. 2 has only one arrow leaving it. 4 has only one arrow leaving it. 5 has only one arrow leaving it. Okay, that's functional. Inputs, each input has exactly one output. It does not matter, notice it does not matter that one of the outputs has 2 inputs. It only matters how many outputs does each input have. Each input is only allowed to have one output. Okay, the reverse of that would be dysfunctional. If we had 3 goes to 9, 4 goes to 10, and 4 goes to 15, this would not be a function. Okay, 2 arrows are leaving 4. All right, this input has more than one output. Similarly, if an input had no output, if 3 didn't map to anything, then we would not have a function. All right, so in a mapping, you want to see exactly one arrow leave from each input. On a coordinate plane, question is, does each x value have exactly one y value? So what they usually use is called a vertical line test. If there is nowhere along the graph where I can draw a vertical line that goes through my relation 2 or more times, then I have a function. Okay? If I cannot do this, all right, this line goes through the relation 3 times. This vertical line goes through the relation 3 times. Okay, if nowhere along the relation can I draw a straight up and down line parallel to the y-axis that cuts through the relation more than once, nowhere along it can I do that, then I have passed the vertical line test and I have a function. If, like this green thing, I can find one place or more than one place where I can draw a vertical line that touches the relation 2 or more times, then the relation is not a function. Okay, it means that one x value goes to, in this case, 3 different y values. Same kind of thing if I have a table or if I have ordered pairs. I'm looking for the same number in my input going to 2 different numbers in my output, or 2 different values in my output. If that does not happen, if each of these values in the domain only go to one value in the range, then I have a function. Okay? If, on the other hand, one value or more than one value maps to multiple possible range values, then I don't have a function.